This screencast is for Section 1.3, adding and subtracting integers. Integers are like the counting numbers, 0, 1, 2, 3, but they also include all the negative counting numbers, like -3, -2, -1, for instance. When you see that little negative symbol, we pronounce it -1, or you can think of opposite of 1. Same thing whenever we introduce variables. If you saw -x, you could also pronounce it the opposite of x. Just to show you how negative numbers work, let's first look at a positive number, the number 3. The number 3 is right here on the number line. That means it's 1, 2, 3 units away from the origin, or 0. The number -3 is right here on the number line. It's 1, 2, 3 units away from the origin, but in the opposite direction. Also, it's important to note, if a is any integer, then the opposite of -a is a. In other words, two negatives cancel themselves out. When we add integers, sometimes it's pretty easy to do. The addition of integers is pretty simple whenever we have two positive numbers. For instance, 3 plus 2 we know is 5. That's because on the number line, once we get to 3, I'm just adding 2 more in the same direction, and I end up at 5. When we use negative numbers, it's a totally different story. I'm going to have to go in the opposite direction. So I want to go to 3, and then for this -2 part, I need to return backwards in the other direction. I'm going to land at 1. You can think of negative numbers almost like subtraction. All right, for the next one, let's look at -3 plus 2, so starting with a negative number. If I start with a negative, I'm going to be down here at -3. But then I add +2, so that's moving to the right 2 units. And I end up at -1. Last one, two negative numbers. For these two negative numbers, I'm moving to the left twice. I'm down at -3, and then an additional 2 more in the left direction. So I end up at -5. All right, let's go ahead and look at subtraction of integers next. Subtraction and negative numbers are really the same thing. You can see up here on this important statement, if a and b are integers, then a minus b is equivalent to a plus a -b. So let's look and see how that affects subtraction of integers. On this first one, 6 minus 13 is just like 6 plus a -13. In general, instead of doing a number line for each individual question, what we want to try to think of is when you put these two numbers together and you subtract them, 6 minus 13, I end up at 7. The bigger number is negative, so I'm going to go ahead and make this negative. So we'll always subtract the numbers if you have one positive and one negative. The larger number will tell you the sign of your answer. In this next one, 9 minus a minus 12, we have two negatives right together. Property says that you can change those into plus. So this problem is now converted into 9 plus 12, or 21. For the next one, -8 minus 13, I'm going to change the subtraction into plus a negative. -8 plus a -13. Both of these numbers are negative, so I'll add them up. They're both moving to the left on the number line. So their sum is going to be negative, and I'll get a -21. The last problem also has two negatives, so I'm going to go ahead and change that to a plus and rewrite it as -7 plus 8. This is like the very first problem where one of the numbers is positive and one of the numbers is negative. So I'll subtract them. 8 minus 7. The larger number is positive, so I'll leave it as a +1. Now, it's important to note that all of these problems could have easily been done on a calculator, but we're trying to do them using mental math skills. So try to avoid using a calculator to actually compute your answer, but if you'd like to check it, you're welcome to do so. For the last part, we want to work on evaluating algebraic expressions that contain positive and negative integers. For all of these, you're going to be given an algebraic expression and then some values to substitute in for them. The first one is x minus y. X is negative 12 and y is 20. So I'm going to do a substitution. Instead of writing x, I'll replace it with negative 12. Instead of writing y, I'm going to replace it with 20. This is the same thing as negative 12 plus a negative 20. Both numbers are negative, so we're getting farther along to the left on the number line. I'm going to add them up. That's negative 32. For the next expression, a is negative 8 and b is negative 6. But you see there's already a negative sign in front of the a. That means we're going to have an opposite of negative 8. So that extra negative that was in front of a will carry down into this part. Those two negatives in the beginning, right here, are actually going to turn into a positive. One of the numbers is positive, the other is negative, so I'll subtract. 8 minus 6 is 2, and I'll leave it positive since the 8, the larger number, is positive. For the last problem, x is negative 14 and y is negative 7. Here again, in the very beginning of this problem, there's already a negative there in front of x. So I'm going to have to include that whenever I substitute negative 14 in. Opposite of negative 14 minus the y value of negative 7. Both numbers have a double negative with them. So I'm going to go ahead and change both to plus. This problem ends up being just plain old 14 plus 7, or 21. Integers take a lot of practice. It's just a lot of arithmetic that you have to use mental math for and to practice on. Okay, good luck.